Yeah. Hello, everyone. It's time for us to begin the Savnet meeting now. So welcome you all to the Bangkok for the ITF 122. So first is Notewell. So Notewell is just a reminder for the ITF policy in effect on the various topics such as the patents and the code of conduct. So it is only meant to point us in the right directions. So maybe there are some exceptions. The detailed definition for the patent policy and the contribution and the participation are set in the BCP 79. So please read it carefully. The main point for the note well is the following. The first is by participating in the ITF, you agree to follow the ITF process and the policies. And the second is if you are aware that any ITF contribution is covered by some patent, it is related to your company, please you must disclose that fact or do not participate in the discussions. And the third is we must remind you as a participant in the ITF, your any activity about the written audio, video, and the photograph will be recorded and may be made public. The fourth is your personal information you provide to the ITF will be handled in accordance with the ITF privacy statement. The last is just want to remind all of us that as a reminder of our attendee, you should agree to work respectively with other participants, especially during the discussion process. So this is general notable policies. So here is the working group status of our working group. Currently, we have already 6 working group document, and we before the ITV meeting, we have adopted the Savnet savvy capability working group working document, and there is another the Savnet intra-domain problem statement has passed through the working group last call and in the is prepared for the IESC review. And currently there are already 22 about active internet draft that related to our solutions, and about the 10 update after the last meetings. So here is the goal of the our this meeting. The first part we will discuss the intra-domain Savnet architecture and related solutions, and we want to make some clarification for or some discussion for where to for the question about where to deploy the service rule within the intra-domains. So for example, in edge or border or internal routers. And we have now several intra-domain proposals. We want to find some solution to converge them. A second part is the inter-domain architecture and the solutions, just for some update for the problem statement and the architecture document. And we also want to compare some newly proposed interest service solutions with exist and compare their pros and cons. The last is some management document. How about, for example, for the how to carry the service rules from various sources, routine source, and some young data model for the management of the service on the device. So this is the chapter agenda. I think you have all seen it, so I will not explain it in detail. There are about 11 topics for our meeting, so I think the time slot very tight. So I think I want to remind the printer make do some clear expression and when you make the practice. So this all for the chair slide. Hello, Joe. Do you have uh, other comment for the chair slide?
I have nothing to add. It should be kept, well, actually, now that I think about it, should be kept in mind if when we have the presentations which get into solutions, that the Savnet working group is very restricted on what it can work on in terms of solutions. Overall approaches, architecture, those are in our remit. Changes to protocols owned by other working groups are not in our remit. And presenters will be making an effort, but probably won't perfectly stay within that bound. It's inevitable. It's not a criticism of them. But in terms of discussion, we need to focus on the general aspects, not the protocol specific properties.
Okay, so I want to repeat the Joshua comment. So in Savnet working group, we will focus on the solution and architecture. The related protocol proposal will be dealt with other working groups. Okay, so let's begin the first presentation.
Okay, good morning, everyone. I'm Shuai from Zhongguancun Lab, and I'm going to introduce our progress on source address validation deployment status. I have give some presentation. I give some presentation since Ietf 118, and we have formed this draft in this Ietf meeting. IP spoofing is one of the long-standing threats in the internet, and so is very important for protecting networks from IP spoofing attacks. And so can be characterized into two classes: outbound SOW and inbound SOW. For OSOW, the filtering is applied as a network edge to traffic coming from inside the customer network to the outside. And for SOW, the filtering is applied as a network edge to traffic coming from the outside to the customer network. The Manners initiative considers IP spoofing as one of the most common routing threats and has defined a recommended action to mitigate the spoofing traffic. However, only 1.6% of routed AS participate in Manners, and not all Manners members follow this action to implement SOW for their networks. So there is a lack of comprehensive knowledge regarding the current status of SOW deployment across the internet community. As a result, this document aims to provide a comprehensive view about SOW deployment in the internet. So we will list some measurement methods and the measurement results about the deployment status using these methods. I will briefly introduce the measurement method. First is the most known one, client-based method. By deploying a client on a host in the audited network, the client can actively generate and send a spoof package to the outside of the audited network. So using this method, we can measure the filtering depth. So a client can incrementally set TTL of spoof packets, and thus its forwarding paths can be learned in a way like traceroute. And we can also measure the filtering granularity. A client can generate spoof packets with arbitrary IP addresses as is the source address. Similarly, we can also use this method to measure deployment of ISL. And we also propose DNAT, destination NAT based method. So specifically, when matching DNAT rules, the DNAT devices changes the package destination to a precise address, but leaves the source address unchanged. This is a spoof packet. So by recording the forwarding path of this spoof packet, we can know the filtering depth and the filtering granularity. And for ISO measurement, the first method is result based, and the scanner first sends a DNS query with a forward IP address that belongs to the OTT network to a DNS resolver in the targeted network, and then the scanner sends a nested DNS query to the same target IP address. Then comparing the results of the spoof query and the nested query, we can infer the deployment of ISO. And for SMPv6 based method, we can use the rate limiting mechanism of IP SMPv6 as an observer to check whether the spoof packets have been received. And for IP ID, we use the incremental IP ID value as an observer to check whether the spoof packet has been received. Similarly, the PMTUD based method also send SMP packets to big message with forward source address to the server. And if the spoof packet reaches the server will reduce the MTU. We use this method to measure self-deployment in the internet in the last month. And we found that about 67% of the tested IPv4 ASs and 72% of the tested IPv6 ASs like any SL deployment. And second, partial SL deployment is observed in 30% of IPv4 and 23% of IPv6 ASs. This suggests that this ASs deploy SL as their access network. And the third, about 14% of IPv4 ASs and 17% of IPv4/24 prefixes demonstrate a complete OSL deployment. Next, over 90% of the tested IP addresses deploy OSL within 2 hops away from the endpoints, and the prefix length of /20 to /24 dominates OSL deployment. This prefix length corresponds to the standard IPv4 allocation units for ASs. Hence, we guess that OSL is predominantly deployed as AS border interfaces. And about 40% of network filter inbound spoofing packets at the /29 to /30 granularity. This suggests SL is predominantly deployed in access networks. For deployment in country origins, China, South Korea, and France demonstrate higher OSL deployment ratios, while Russia, Brazil, and India show lower OSL deployment ratios. For ISL deployment remains limited in most regions, with South Korea, Chinese Taiwan, and Poland exhibiting more advanced ISL deployment. We also compare between ISL and OSL. We found that G Network, Digital Ocean, Korea Telecom, and China Telecom achieves over 90% of OSL deployment, and Changhua Telecom and Korea Telecom, Charter, and Comcast demonstrate significantly higher ISL deployment. We also found a positive correlation between the deployment of OSL and ISL. For example, about 10% of ASs that deploy ISL also deploy OSL. In contrast, only 5% of ASs without ISL, they deploy OSL. And for ISL, about 36% of ASs that deploy OSL also deploy ISL, while only 22% of ASs without OSL deploy ISL. Finally, to understand the impact of manners on SAL deployment, we compare SAL deployment ratios between manners and non-manners networks. This including both full and partial deployment. And we found that manners network demonstrated superior SAL deployment. For OSAL, about 29% in manners networks have deployed OSAL, while only 19% in non-manners networks. And for ISAL, the number is 73% vs 56%. This result indicates that Although anti-spoofing is only a recommended action, Manor's participation improve self-deployment across network configurations. Okay, I will stop here. If you are interested in collaborating or have any suggestion on how we can enhance our measurement results or measurement method, please reach out to us. Thanks.
So, okay.
If anybody has any questions, put yourself on the queue, and then if you're in the room, come up to the microphone. Okay, Tobias, go ahead.
Tobias Siebig, Max Planck Institute for Informatics. I was wondering whether you validated that the finding that most ISAF is in access networks is not an artifact of the methodology, and if so, how you did that validation.
Sorry, you mean how we validated the SR result?
How you validated that your results concerning ISAF being prominently deployed in access networks is not an artifact of the measurement methodology.
Sorry. We evaluated the SR measurement by combining different methods, including just we talked before, SMPv6 method and DNS resolver-based method. We will combine the results of different methods.
Yes, but in access networks, you, for example, should not find that many resolvers. So the question is there something about access networks which, given the methodology, might make them look more ISAF deploying?
Sorry, I can't hear you clearly.
It might be better if we take this offline.
Yeah, okay, thanks. I will talk offline. Yeah, thanks.
Okay, thank you, sir.
Okay, should we start?
You can control it.
Okay. Hello, everyone. This is Minqing Huang. I'd like to give a very quick introduction about the latest update about general source address validation capabilities. So here's the latest progress since last meeting. First, we conduct a poll on whether we should, reintroduce the mode 4 into the draft. And per the conclusion of the poll, we updated the individual draft to the version 08. And then we initiated a working group adoption call. Based on the feedback, we updated the draft accordingly. So here's some details about the updates. First of all, as I just mentioned, that based on the poll, we introduced the mode 4 into the draft. So as you can see now, we have 4 SAF modes here, 2 for interface level and 2 for route global level. So the mode 4, as I mentioned, that we introduce it, and then it is prefix-based interface block list. So why we do that? So based on the discussion and the poll, we realized that we do have some unique values, compared to other modes, the mode 4. For example, when we want block or view interface for a specific prefix, that we most efficient compared to other modes. For example, even though we can achieve the similar functionality with mode 4, for example, we configure on each interface, right? We can also block that specific source prefix. And also we can block it in a very long list of interface allow list for this specific source prefix, but that is not as efficient as mode 4. The typical scenario for this mode 4, for example, we want to block for DDoS attack, right? We want to block a few interface for a specific source prefix, or we want to block one interface for our inter-source prefix protection like that. So they do have some kind of unique scenarios. This is why we introduced the mode 4 into the draft. And accordingly, we update the validation procedure, right? Besides, we add mode 4 into the preview. I want to emphasize some more rules, principles that we want to. One is that we have kind of a mutual exclusive for two pair of the modes. For example, the mode 1, mode 2, these two are interface-based source validation. So these two should be mutually exclusive. That means you cannot configure these two simultaneously for one interface. Similarly, we cannot enable mode 3 or mode 4 for a specific source prefix simultaneously. So in case if you some kind of mistakenly configure or enable these two pairs simultaneously, what kind of principle we suggest is that mode 1 and mode 3 should be preferred. So this is about update about the validation procedure. And also, right now we are at the working group items, version 00. I want to express our thanks for all working group members for your valuable comments, and especially Ajin. And also we want to thank to the some Mixing or and Changwang from the perspective of vendor's view, right? Because this kind of stuff is very related to what kind of capability your routers have. Okay, that's all. Any comments?
So I think Jeffrey has some question, and Lisa, you can respond in the chat. Okay, thank you.
Hello everyone, I'm Lan Chengqin from Zhongguancun Lab. In the past few months, there have been many discussions on where the sub-rules should be deployed. And the current Intra-domain Savnet architecture has described how to use the sub-specific information and how to design the sub-specific information communication mechanisms and how to generate sub-rules at a high level, but it doesn't specify where to use the sub-rules. So I'm going to introduce a summary of all of those discussions on this topic. Let's have a quick review of the goals of intra-domain subnet architecture. The first goal is avoiding blocking legitimate traffic, which is one of the most important requirements of the new intra-domain sub solution. And the last two goals define which spoofing traffic needs to be blocked by intra-domain sub. Specifically, it needs to block spoofing traffic from a customer network or a host network that uses a source address of another network. For example, in this figure, the customer network may originate data packets using a source address of prefix P3, which belongs to the host network, or use a source IP address of prefix P4, which belongs to an external AS. This kind of spoofing traffic should be blocked by intra-domain sub. And the third goal requires that intra-domain self needs to block spoofing traffic from an external AS that uses a source address of the local AS. In this figure, it shows an external AS uses a source IP address of prefix P1, P2, or P3, which belong to the local AS. This kind of spoofing traffic should be blocked by intra-domain self. Okay, so according to the goals, a straightforward deployment scope of intra-domain self is on the edge of the router network. To meet the second goal, we can deploy SAV on customer-facing routers and host-facing routers on the interfaces facing the corresponding customer network or host network. And to achieve the third goal, we can deploy some on AS border routers and perform some on their interfaces facing an external AS. Yep. But some on inner routers, in addition to customer-facing routers, host-facing routers, AS border routers, some on inner routers may also can perform sub on interfaces facing a neighboring routers, but there have been a lot of discussions on whether this case should be considered. Since Ietf 120, many people have discussed the problems and considerations of sub on inner routers on the mailing list, and their common view is that it's challenging to perform sub on inner routers for a generic topology with IPFR, traffic engineering policy, or asymmetric rules inside the router network, because the computation of sub-rules would be very complex and burdensome when considering all of those factors. And according to these discussions, we have revised this document and we presented the revised document in Ietf 121 to clarify the feasibility of sub on the edge and the difficulty of sub on inner routers. And we had received comments from Peter and Joe, and they understand why edge deployments and edge implementations are simpler. And Joe also suggests us to clarify what do we get when only parts of the edge are covered. So after that meeting, we continued the discussions on the Savnet mailing list and recommended that sub on the edge should be preferred. So we plan to add some descriptions on incremental benefits of sub on the edge in the next version of this document. Specifically, when only parts of the edge have deployed sub, it can provide incremental benefits. The routers that deploy sub can block spoofing traffic from the facing network. So the AS will be only vulnerable to spoofing traffic entering from those parts of the edge where sub has not been deployed. For example, in this figure, if router A, router B, router D, and E have deployed sub on the edge, spoofing traffic from the custom network and other ESs will be checked and blocked. And only the host network connected to router C, which doesn't deploy sub, can send the spoofing traffic. By understanding the incremental benefits of sub on the edge, network operators can plan their incremental edge deployments. And here is a summary. Sub on the edge of the router network has advantages in terms of feasibility and effectiveness. First, edge implementations and deployments are simpler. And secondly, as suggested by the manners, to be as effective as possible, sub should be applied as close to the source as possible. So sub on the edge is closer to the source. And it may have an issue of incremental deployment. That is, it may take time to achieve full deployment if there are many edge routers in AES. But it should not be a big issue because it can provide incremental benefits by blocking partial spoofing traffic. And the deployment complexity depends on the design and implementation of the new solution. As for self-on inner routers, it could have an advantage in some specific topology. As mentioned by Aijun, by performing self on certain inner routers, it may help block more spoofing traffic when only parts of the edge have deployed self. But it faces an issue of the difficulty because factors including IPFR, TE policies, and asymmetric rules inside the router network may affect the accuracy of self on inner routers, and they are difficult to address. So according to all of the previous discussions and comments, we plan to provide the following recommendations on how intra-domain Savnet should be deployed to ensure the desired goals are fulfilled. We think self on the edge of the router network must be considered to ensure the goals can be fulfilled because it's simpler, more practical, and more effective for generic topology. And self on inner routers can be considered, but is not required. It's because the difficulty. If it's considered in a new solution, the factors that may affect the accuracy of self on inner interfaces need to be taken into account. Yeah, that's the summary of discussions and what we plan to improve this document. Thanks.
So, so if there is no other person ask question, so I want to discuss with you for the deployment of the survey within the intra-domain. In my understanding, as I described in the mail list previously, that there are some situations that deploy survey in some special internal router may be more efficient than deploy the survey rule on all of the edges. So I think we should consider to give the flexibility to the operator to select where to deploy it, and do not restrict them to deploy, can only deploy on the edge routers. For your difficulty that you read for the deploy within the internal router, I think for example, the FR or TE, so I think the such action, traffic engine action, should be deployed in advance. So we can utilize the service-specific information to transfer the design of the policy route to other internal router in advance. So that is open the related interface in advance. So there are some solutions. I think we can overcome such difficult.
Yes, I think addressing these factors is challenging, but may not be impossible. We should pay some overhead to compute these factors, but the computation would be very complex. So to ensure the goals can be fulfilled, I think cell on the edge must be considered. And if the solution want to consider inner routers, it's okay. We are not forbidden that.
Okay, Jeffrey.
Thank you. I try to keep my comments short. Jeffrey Haas. The difficulties I think that are seen for trying to do intra-domain SAV is that you can't do things across all of the network using the procedures. This is where the inappropriate drops happen for like the FRR cases and such. As you're discussing in your presentation, access networks, access interfaces are an appropriate place to do these types of filters, or networks that are carefully behind specific interfaces facing access networks. And this means that when you can, and many places already do 802.1x filtering, that programs the source address filtering as part of their firewall policies. That helps, but in devices that may want to help do this sort of filtering using SAV as a forwarding plane mechanism, selectively enabling it on those interfaces or on specific networks can help this be successful. But if you try to expand it to solving the network-wide problem through, like, as prior presentations have had, like through an IGP, that doesn't always work well.
Okay, thank you. Okay. So I think for deployment area, we can discuss further on the list. Okay.
Hello.
Yeah, we can hear you.
Thank you, Chair. And hello, everyone. This is Wei Wang from China Telecom, and I will give a very brief introduction about the new proposal we update for the intra-domain source address validation solutions. And yes, because the presentation from Lancheng have gave a very detailed problem statement, and the background introduction about the sub mechanism. So we will just give a very brief introduction about the background and objectives. The background for the intra-domain sub aims to prevent outbound packets from spoofing source addresses of other subnets or AS, and inbound packets from external AS from spoofing local AS source addresses. And our objective is to find a general solution to host-facing, customer-facing, and AS border routers, and to simplify the SAF rule generation based on FIP table. And for the AS border routers, it should learn all the intra-domain prefixes from IGP protocol at first, and like the router 1 shown in this figure, and after learn the prefixes, it should generate a block list containing this prefix on the interface connected to other AS, and then it should block packets with spoofed source addresses from external AS that match the block list, and it also block packets with spoofed source addresses of internal links. And for the single-homed house network, the router 5 need only deploy the strict URPF to achieve the desired effect. And it also prevents other spoofed packets, such as the source address is not from P2, and this traffic or packets should not be accepted. And for the multi-homed customers network, to achieve the effect of engineering return traffic based on the granular address space, two cats of routes should be configured on the customer-facing routers. As shown in this figure, the router on the router 3 across route 10.0.1.0/16 and granular route 10.0.1.1/25 are configured, and also has two type of routes configured on the router 4. And this edge routers should deploy the loose URPF to achieve the desired effect. And the packets are, are filtered based on both coarse and granular route matching. The edge routers also can determine automatically when to be strict URPF and when to be loose URPF. It depends on the summary or detailed routers routes configuration. And for the internal routers, in some spine leaf scenarios, like the router 2 in this figure, it is the spine router with its 3 leaf routers. Instead of deploy the intra-domain self mechanism on these leaf routers, the operator can select deploy it on the spine router 2. And once the router 2 deploys the strict URPF, it can safely block the spoofed packet from the host or customer networks. And this is a very brief overview of BMSPF mechanism. The BMSPF is also called bidirectional metric-based shortest path first mechanism. We propose this mechanism in just one LSR bidirectional metric SPF. And with this mechanism, we can avoid asymmetric routing, and the two neighbors use the same bidirection link matrix for the SPF algorithm path calculation. And when routers communicate, packets are transmitted through the same path, and the same interface is used for sending and receiving packets between two routers in an AS with fully deployed BMSPF. And yes, BMSPF based SAF solution can simplify the intra-domain SAF by leveraging symmetric routing. And the new intra-domain SAF solution has the following characteristics. The first is the consistency. The SAF procedures in the internal host-facing and customer-facing routers are the same, and the AS border router procedure cover all relevant prefixes, and it can cover all types of routers, such as host-facing, customer-facing, and AS border. And this solution can cover all of them in different scenarios. And that's all. And any comments?
Yeah, Peter.
Peter Pshenak, Cisco. So I appreciate you trying us to convince how life would be wonderful if we can use this bidirectional metric SPF. But I think the crux of the problem is that that is an unrealistic assumption that we can equalize the metric from both sides. So I think this draft is not the important one. The important one to discuss whether it is the bidirectional SPF draft, whether that is a good idea or not.
Yeah, let me try. Currently we just want to find one general solution that cover all the type of the routers. So normally the routing within the intra-domain is semantics, and because we will configure the link cost in the bidirection is the same. But if there are very seldom the situation that the metric is the metric value of the one link is different. So in such situation, we can deploy the BMSPF algorithm to keep the routing within the internal service is semantic. So
I understand what you are trying to do, but what I'm trying to say is that that is not the reality. People do deploy asymmetric metrics and they want to keep them that way. You cannot basically claim that having an asymmetric metric on any link is an error. It is not.
Yeah, I know. We cannot also the semantic routing within one intro domain in any time. So we should use we can also the BMSPF feather to be supported within one domain, within one intro domain. So if we can collect such information or such capability of the internal router, we can also the routing within one intro domain will be semantic.
Well, you're trying to make it symmetric artificially. That's all I'm going to say. Thank you.
Oh, thank you. Serial.
Can you please go to your, I'm Sriram from NIST. Can you please go to your slide 4? Yeah, I think you are on that. So I'm wondering why the router R1 on the outbound interface, it's doing intra-domain SAV. It should just be doing inter-domain SAV. And out of the allowed list, it can simply remove P1 and P2 if they are known to be customer prefixes or internal prefixes.
Thank you. I think the problem of the intra-domain as is proposed in, I think, maybe an working group document, and it said the intra-domain self procedure should solve the three scenarios. The first one is for AS border routers, and the next one is for the customer-facing or host-facing routers, and the last one is for internal routers. And these three use cases are keep consistent with the problem state and architecture working group document.
Okay, thank you.
Thank you.
Hi, Lancheng from Zhongguonceng Lab. Could you show the page 5? Yes. In this case, if you deploy loose UIPF on interfaces facing a custom network, it could block some spoofing traffic using a source IP address, which is not covered in the FIB, but it cannot exactly meet the goals. Yeah, it cannot block spoofing traffic using a source IP address, for example, of prefix P2 if you use loose UIPF. So this is the problem. And I think we need to find a new solution to achieve a more accurate sub on this place. And please turn to next page. Yes. So I think as just recommended in the intra-domain sub architecture document, I think IPFR and T policies and more factors should be discussed in this case if you consider sub on internal routers. Thanks.
Yeah, and I will respond quickly. For your mention for the loose URPF, we will think some update to prevent the customer to spoof the P2 prefix. I think it should be updated. Okay. Thank you. Okay, so let's to the next presentation. Thank you, Wei.
Thank you, Chair.
Good morning, everyone. I'm Li Binliu from Zhongguan Lab. Today, I will present the draft for gap analysis, problem statement, and the requirements for source address validation in inter-domain networks. This document provides a gap analysis of existing inter-domain some mechanisms, describes the problem space, and defines the requirements for technical improvements. This is a summary of our historical versions, and today I will present the workgroup version 08. This is a summary of the comments and our corresponding responses. Joe commented that the sections 4.1.3 and 4.1.4 seem to focus on the attacking rather than spoofing. Mitigating attacks is not in the scope of the work group. In fact, the original scenario described in the two sections are attacking, but the root causes for these attacks is source address spoofing. And Joe further commented that the emphasis in the it does not matter who the false source is attacking or why. The question Savnet cares about is that it is a spoofing traffic along a certain path. So focus on that, not on distracting purpose. Yeah, we agree with that. We have already revised the scenario descriptions in sections 4.1 and 4.2. Make the scenarios focus on source address spoofing traffic from within the customer cone and from a provider or PRES. Okay, Joe also commented that the section 4.1.3 seems to describe a situation that there is nothing S4 can do, as it cannot distinguish the traffic from S2 that is correctly from S1 or from a spoofer connected to the S2. Actually, the scenarios in Figure 5 in section 4.1.3 describe a case that the forwarding path of the traffic is with source addresses in P1 is S1 to S4, and the legitimate traffic will not reach H4 via the S2. So that's the traffic with source addresses in P1 from S2 is spoofing traffic. Joe further commented that that I think you are trying to get at the case the traffic goes directly from S1 to S4 from the prefix P1, but not via S2. So the inclusion of the advertisement from S1 to S2 with no export will confuse the readers. So the text would benefit from writing. Yes, correspondingly, we have revised the figures to clarify the scenarios that describe existing sound mechanisms may have improper permit problems in section 4.1. And there are two more comments from Joe. The first one is that section 6.1.1 describes that the solution should provide improvement. But it seems to him that as a requirement, any solution must provide improvement, at least in many cases. If it does not, then there is no incentive to adopt. So yeah, we could also agree with this suggestion, and we have updated the requirement to it must avoid improper block and permit less spoofing traffic than existing sound mechanisms. And also correspondingly, in section 6.1.2, it says that the mechanism should not assume pervasive adoption. This seems to permit the proposals for solutions that would require pervasive adoption. So Joe commented that unless we can provide an explanation of when and why it would be acceptable to adopt a solution with such a requirement, he thinks that we should make this a must not. Yes, we already modified that statement to must not in section 6.1 and point 2. This is a summary of the main updates of this draft. We have summarized the problems of existing some mechanisms and technical requirements for a new sub-solution in section 1. And we also have required a term, real forwarding path to active forwarding path according to the suggestions of co-authors and give its definition. And we also updated the review contents of existing some mechanisms in section 3. And in details, we have updated the descriptions of ACL-based ingress cell filtering, and we have simplified the contents about VRF, URPF, and removed the source-based RTBH filtering. And we have updated the gap analysis of existing cell mechanisms in section 4. And we, according to Joe's comments, we have removed all the attacking scenarios and all the corresponding descriptions. Instead, we have added the scenarios which describe the source address spoofing traffic within a customer cone and from applied or PRES. Also, correspondingly, we have removed all the contents related to VRF URPF and the source-based RTBH for the gap analysis. And we have improved the presentation of the problem statement in section 5, as well as the descriptions of the requirements for a new inter-domain cell mechanism in section 6. We have removed the comparisons for cell using different cell-related information individually. And we discussed the available cell information sources, which are useful for improving the validation accuracy. Here, we have discussed VRF URPF and source-based RTBH and explain why we remove them from this draft. For VRF URPF, in section 3, actually, we focus on reviewing existing cell mechanisms for obtaining a cell table. We co-authors discuss VRF URPF. Actually, it is not a method for computing a cell table. It is only a way of implementation once we have got a cell table. So currently in section 3, we only illustrate it and removed it from further gap analysis in section 4 and problem statement in section 5. And for source-based RTBH, we also discussed it further and said we may not include it in see it as a cell solution because source-based RTBH reacts and does damage control when DDoS attack is already happening. So when the victim as will signal a specific prefix or IP address to the neighbor AS. Okay, so we should not include it in the draft. Okay, this is a simple discussion about the draft. We have also already included the cell-related information sources in the section 6 for technical requirements, including local routing information, RPKRLA, and other objects, and cell-specific information. So this document recommends this.
Sorry, I think you should leave some time for your next presentation.
Yeah, I will reduce the time.
Okay.
Okay. So this document recommends the information sources which are useful for improving the validation accuracy. But instead of not comparing the cell table results using them for cell individually. Okay, here I want to summarize the problems of existing mechanisms as well as the technical requirements here using 2 slides. Currently, the problems of existing cell mechanisms are improper block, improper permit, and high operational overhead here. And here is a summary of the requirements for a new cell solution. To address the problems we proposed in the previous slide, this document outlines the technical requirements for a new solution, including improving validation accuracy over existing mechanisms, reducing the operational overhead, working in incremental or partial deployment, and providing necessary security guarantee. Especially a new solution should secure the communicated information between AS if it requires exchanging the specific information between AS for sub and guaranteeing convergence. Okay, so for all of this, we have consolidated these points in the introduction section to facilitate the reader's rapid comprehension of the document's key points. Yes, many thanks to all the people from our community for their helpful comments and feedback on this document. Okay, next step, we request a workgroup last call for this document. Thank you. Any comments?
Sriram.
Yeah, this is Sriram, NIST. I'm a co-author, and I have a quick comment that I was suggesting that we should use feasible paths instead of active paths. We cannot know the active paths. Active path at a given time would be one of the feasible paths. So we can take this offline and once again properly discuss that. I feel that feasible paths would be a better term rather than active paths. And the community, the SAV community, is used to the concept of feasible paths. Active paths are kind of hard to go after. We can discuss this offline.
Yes, I think we have discussed it offline, and we have made some revisions on section 6.1.1. You can look at it. If you have further suggestions, we can discuss it offline. Yeah. Thank you.
Yeah, Minqing.
Yeah, actually, I want to add comments about the what Sriram mentioned. The first of all, we all know that currently the solution what we have are all based on feasible paths. So that we already have a good solution to solve kind of this thing. But what I want to mention is that the distance between end user and the network is get farther, and the more flexible path will get involved. So the source spoofing may, take advantage of that. So I think we may want to go further to do something about this kind of thing to avoid that the make advantage of the feasible path. Indeed, that is a challenge, but I think that is, valuable. Thank you.
Okay, let's go to another draft for source address validation in inter-domain. Sorry.
I give you control.
Yeah.
Is this document?
No, it's still problem statement. The architecture draft, yeah.
Not.
Okay. Sorry. So the inter-domain Savnet architecture aims to provide a comprehensive framework for developing new inter-domain sound mechanisms. It aims to address the problems of existing mechanisms and meet the requirements proposed in the inter-domain Savnet problem statement. We have updated the 2 workgroup versions. Today, I will present the workgroup version 01. This is a quick review of the whole version. we have summarized the incentive or inter-domain Savnet architecture and illustrated the design goals and introduced the detailed information about the architecture, including the overview, some specific information and the general information, and the sub rule generation based on various sub information sources. And we have described the various Savnet communication mechanisms, including sub-specific, general information, and the management information communication mechanisms. We also illustrated the use cases of this architecture and also described how to meet the design requirements proposed in the problem statement draft. Yeah. This is a quick overview of the Savnet architecture. Here we show the classic business relationships between AS and how an AS can collect the different sub-related information sources from various information sources. For example, SX has deployed the Savnet agent, and it can communicate with its customer AS, which also deploys the Savnet agent to communicate the sub-specific information. And the SS can collect the RPKI ROA and the ASPA objects from the RPKI cache server and obtain the local routing information from BGP messages, as well as the RR data from the R database. So SS can consolidate all of this sub-related information from different sources to generate sub rules. This is a summary of the comments and our responses. This comments are from CRM. It is mainly about the priorities recommendation of different sub-related information sources. We have discussed it. These comments are from the mailing list during Ietf 121 and the workgroup meeting. He commented that the draft emulates 5 types of data that can be helpful to construct sub tables, but it seems premature to assign priority labels to them. And in any case, the draft also says that they are complementary to each other for sub. And he suggested that we remove the priority recommendation for the different types of these sources. Yes, we have do some revision for the recommendations of different sub information sources that we discussed with RAM. And here is the updates on recommendations for using the different sub information sources. Currently, the architecture recommends using the information from these sources, which are verified as trustworthy to generate sub rules. And sub information, each sub information source complement each other for sub. The table summarizes the sub information sources and their trustworthiness and how to use them to generate sub rules. For sub-specific information, HAS, which deploys the inter-domain Savnet, can utilize a specific security mechanism to validate the received sub-specific information from other AS to guarantee its trustworthiness. And for RPKI, ROA, and ASPA objects, they use X.509 certificates to protect the objects and guarantee their trustworthiness. For local routing information, they may rely on some techniques such as ROA and route leak detection to achieve the trustworthiness. And for IR data, they may have lower level trust than the information sources above. So for security considerations of this draft, the security threats faced by sub-specific communication mechanism in inter-domain networks can be characterized into 2 aspects. Security session threats, including session identity impersonation and the session integrity destruction. And the content security threats consists of message alteration, injection, and path starvation. So existing security mechanism can be considered, or a new security mechanism should be designed to secure the information. Okay, many thanks to all the people for the comments. And thank you. Any comments?
Okay, so if there is no any question, we will move to next presentation. Okay, thank you.
Thank you.
Sir, wait a moment, I will share slide to you. Yeah, you can begin.
Yes. All right. So, so this talk is about the BARSAV. We did some updates to the draft. Again, my name is Sriram from NIST, and my co-authors on this are Igor Lubashev from Akamai and Doug Montgomery, also from NIST. So this is about updates to the BARSAV draft. The next slide, please.
You can control yourself.
Yeah, I can do that, I guess. Yep. So there are basically three changes that I would like to discuss today in the draft. The main one is about a detailed algorithm for BARSAV on the provider interface. We used to have a outline of that methodology, but now we have a detailed algorithm. There's some minor tweak to the existing algorithm for BARSAV on the customer or lateral peer interface. And the third one is a question regarding a clarification regarding the direct server return DSR, if it can be a customer or a lateral peer. So those are the three. So the precondition for BARSAV on the provider interface, those are essentially that even if you look in the so the AS is doing SAV on the ingress packets coming from a provider, a transit provider, and looking towards the customer cone, the preconditions are they are actually the basic prerequisites for BARSAV in the customer interface. And one of them is that the AS within the customer cone attaching no export must have ASPA registration. And another one is a prefix within the customer cone associated with DSR must have ROA registration. With that, the basic principles. So once we have that, and we're not asking for a complete deployment of ROA and ASPA, a full adoption within the customer cone. We are just saying that if you have a no export situation at your AS or a DSR situation, please register the appropriate ASPA or the ROA, and that way the hidden prefixes can be uncovered. So once that is given, the two main principles of BARSAV on the provider interface are number one, we want to subtract, we want to do lose URPF because to start with, we want to use the allow list that comes based on lose URPF. And we are looking at the provider interface, so pretty much most of the prefixes of the internet will be received on the provider interface, assuming the provider is sending a full table. So therefore, we start with the lose URPF and then subtract prefixes that are internal on the customer cone side. So we look at the prefixes on the customer cone side, the prefixes whose routes are arriving on the customer interfaces. We look at them, and any prefix that is known to originate exclusively within the ASS customer cone, those prefixes can be eliminated, provided that there is another condition with that. So the first one, the way we know that the prefix originates exclusively within the ASS customer cone we can determine that on the basis of ROAS. So we look at the ROAS of every prefix that we have found in the customer cone using the regular bar-sav algorithm, and we look at the ROAS of that prefix, and if the ROAS indicate that there is no origin AS outside the CC, the origin ASs are exclusively within the customer cone. So that's one condition met. And in addition to that, another condition is that every feasible route from the prefix origin to the AS that is doing the provider interface SAV, every feasible route is known to propagate exclusively within the AS. And that can be determined by looking at all the feasible paths, which we already know the customer cone and the AS relationships based on the regular bar SAV. So using that, the knowledge of the customer cone, we can compute all the feasible paths from the prefix origin to the AS doing to the SAV. And if any of those routes have ASs in the AS paths, and if those ASs are pointing, the ASPAs of those ASs are pointing outside the customer cone towards one of its provider ASs. In other words, the ASPA indicates a provider AS which is outside the AS's customer cone, then we eliminate those prefixes. So if these two conditions are met, the prefix originates exclusively within the CC, and the feasible route has all the ASs within exclusively also within the CC, then we eliminate those prefixes. So this is illustrated here with a figure, and in this figure, the prefixes on the left, the P1, P4, those are exclusively originating within the customer cone, and they are also propagating exclusively within the customer cone, not making a detour outside of the customer cone. But on the other hand, the other prefixes, P2, P5, P3, they are not the same. P2 has one path that is exclusively within the customer cone, but it has another path where it has a possibility that the data packets can detour out. They can go from AS5 to AS9 and then come down on the provider interface. So so any prefix that we can detect based on ROAS and ASPAs, that it can make a detour outside of the customer cone and then can legitimately come on the provider interface, not only the prefix, actually the data packets with source address in that prefix. So they can have multiple feasible paths. We try to make sure that there isn't a path that goes outside the customer cone. In that case, we won't subtract it, otherwise we would. So that's the gist of the provider interface bar-sav methodology. Just moving on quickly, the little tweak that we did to the regular bar-sav for customer or lateral peer interface is that during the process of the computations, if we find any AS0 or any ASS with IANA special purpose AS number, we will remove such ASS from the set of ASS for the customer cone. That's a simple thing, a good hygiene practice. And the answer to the question that was asked at the last IETF regarding DSR is what happens if the DSR AS is a lateral peer and not a customer cone. The answer is that is well taken care of by bar-sav, because what is required is that the DSR should register a ROA for the prefix that is not being announced. So that's a simple solution for the DSR case, and that applies very well to the customer interface as well as the lateral peer. So with that, I can take one or two questions, I think.
Yeah. Jeffrey have asked you a question in the chat. I think you can answer it. I want to add one question that I have provided you in previous meeting. That you for the bar-sav, the most challenge is that you put all the possible prefix that's owned by one S within the side table, even they are not advertised by the BGP update. So I think it may be the most challenging point for the by-side solutions. If you have any proposal to renew this, I think maybe more better. So I think because time is limited, I think you can reply on the list. Okay, thank you.
Yeah, very quickly, the answer to your question is that BARSAV is very directional. I think what you are concerned about is whether it is losing directionality. It is not losing directionality, and it is fairly accurate in terms of only picking up the feasible paths that can arrive on a specific customer interface. So I'll be happy to clarify that further on the list. Thank you.
Okay, thank you. Oh, sorry. Oh, sorry. Yeah, Suchi, you can begin now.
Okay, thank you. And hello everyone. Today in the Savnet working group meeting, I will present the main updates of our draft on inter-domain source address validation on AS relationships. And previously, RFC 5210 divided the SAV architecture into 3 levels and proposed an inter-domain SAV system based on AS relationships. So we adopted an inter-domain SAV system So we adopted this idea and proposed our scheme using AS relationships to abstract inter-domain rules. We have made several updates since our first submission of our draft, and we have made an oral presentation in Ietf 118 and a significant update in version 2. After our last presentation in Ietf 118 Savnet meeting, we received several comments, and we responded all these comments in our later updates. Firstly, the chair proposed that draft 01 needs in the draft 01 that each AS needs a centralized server. This may lead to higher upgrade costs. So we updated the design in our section 3. We modified it to a distributed SAV system implemented on existing border routers. The second, the chair proposed that our draft 01, the SAV system needs a new protocol to communicate SAV rules between centralized servers. This may increase the cost and make it complex. So we added a feasible implementation of the communication mechanism in section 4. It uses an extension to the existing BGP protocol. The thirdly, that the chair suggested we consider merging our solution with another inter-domain SAV method, the BGP operations. And after several discussions, we compared them and found that they differ in requirements, architecture, and use cases. Therefore, we decided not to merge them. In addition to responses to previous comments, we added an analysis of our scheme in some multi-homing scenarios in section 5. And AS relationships are the basis of our scheme. We mainly discuss 3 major relationships, and below is the export rules between the major relationships. We also discuss 2 uncommon AS relationships, And many methods can be used to obtain AS relationships. One is the direct announcement between neighbor ASs which deploy SAB systems together, and one is the inference algorithms using other information such as commonly used AS rank link, or we can use direct query methods such as using SPA objects in RPKI. As for the architecture, we partly adjusted the intra-domain SAB system in RFC 5210. It has two main components, the validation router and the address mapping server. We take the existing board routers to act as VRs. They are responsible for ASN and IP prefix SAB rule generation and packet validation. And the VRs generate IP prefix SAB rules based on ASN rec SAB rules by querying EMS. About the EMS, it records the mapping from AS numbers to IP address prefixes owned by ASs. At present, information can be calculated using array objects from RPKI. And in our SAB scheme, as the ASN SAB rules updates less frequently, we use BGP update messages to advertise the ASN SAB rule. And to transfer the ASN SAB rule updates in BGP update messages, we try to design a new BGP path attribute and using the format that the TLV format, and while the value field carries ASN sets. Take the simple network in the figure below as an example. When the S3 is newly connected to S1, S1 receives updates of routes and SAB rules, and they propagate it to S2. We also discuss our schemes in some dynamic scenarios, and when AS relationships or address prefixes owned by ASs, when they change, the related ASN SAB rules or IP prefix SAB rules can be triggered to update actively. And all in all, our SAB system handles AS level updates and ignores those fine-grained updates. Based on our proposed solution, we summarize some considerations on SAB deployment. They include about using existing information, preferring more abstract information, and balancing accuracy, time, and cost. And recently, when preparing the presentation, we received more new comments from the chair and about our updated draft. And among all 7 comments, 3 comments focus on the comparison between our scheme and BARCF, mainly on how to obtain AS relationships and how to query IP address prefixes owned by ASs. And we will provide a detailed comparison in later slides to them. And the other 4 comments are about the writing of our draft. We will clarify the definition of different terms and modify those unclear descriptions in our draft in future updates. Firstly, we explain the differences of our solutions through a brief developed timeline here. From the timeline in the slide, we can find that based on the same principle, but through different paths, used maybe not the same methods, we achieve the same goal. And our schemes is mainly based on RFC 15210. And next, we will compare our solutions from the below 3 aspects. Firstly, about how to obtain AS relationships. The BARCF uses SPA and uses BGP update messages when partial deployment. And our scheme uses AS relationships announced between neighbor ASs and take other methods like inference method, algorithms, or query methods, or maybe SPA only as feasible alternatives. And the second one about how to establish the intermediate possible source of AS sets. BARCF queries SPA at a single point and calculates them. And the routers in our scheme propagate updates with BGP extension. And after receiving updates, they calculate further propagation with their export rules between AS relationships and propagate them until the network reach convergence. And the third is about that how to convert AS sets into prefix lists for packet validation. RCF uses ROA objects in RPKI and uses BGP update messages when not fully deployed. And our scheme completes the conversion by querying AMS in our architecture, as the AMS has the same end as ROA in RPKI. We may take ROA in RPKI as a feasible implementation of our AMS at present. And after the introduction and comparison of our scheme, we think that our scheme has advantages and that the list may provide some supplements. The first that we provide support for AS relationships. Our scheme considers more major and uncommon AS relationships and leaves more flexibility for possible new AS relationships. I think this point may need further consideration and discussion as we receive some comments about it. And the second is that as we consider AS owned just query method as ROA is not designed specifically for SAP, and whether to design such specific SAP facilities may need further discussion, and if the facilities are needed, AMS may be retained and maybe provide convenient queries specifically for SAP schemes like us or like other schemes. And the third, that our scheme has good adaptability to changes. And in our scheme, the DSs updates SAP rules actively when the changes occur to the networks, and there's no need for them to wait for notifications after they receive the updates from RPKI. And the fourth, that we think our scheme may have flexible implementation choices, and deployment and gradual optimization of RPKI may be a long process, and our scheme can flexibly choose various implementations of our NS or maybe maybe the AS relationship of obtaining method. And about the next step, we hope we can obtain more complex relationships and connection scenarios from network operators for better further analysis of our scheme. And based on this, we will analyze the effects of our SAP scheme in more practical cases, so we can perform targeted optimization on it. Also, we will further refine our SAP implementations, such as the extension to BGP. In addition, we will optimize them, enhance their security and efficiency, and reduce their overhead to increase deployment benefits of our SAP scheme. And what's more, combined with suggestions and comments towards our draft, we will update our draft and maybe our design of the scheme in future updates. And all in all, that thank you for listening. All comments and suggestions about our scheme and the draft are welcome. Thank you.
Yeah, thank you, Dr. I think the serum has responded to your question on the mail list. So from my point of view, I think these two solutions, there are many points, many overlap between the two solutions. So I think the author of your document or the bar service should compare and to try to remove some challenge in each other's proposals, and we want to find one general solution for the inter-domain saving. Okay.
Yes, thank you. Thank you. Okay.
Now, I think you can begin for the introduction. Okay.
Okay, thank you. Good morning. I'm Nangong from Huawei Technology. Today, I will introduce our thoughts on the inter-domain Savnet solution. We will propose SPA and the SPD mechanisms to help AS to generate sub-rules accurately and automatically. First, I will define some terminologies. First is source AS. Source AS is AS whose source prefixes need to be validated as a validation AS. And validation AS will conduct a source address validation for the packets coming from the source AS. For example, suppose we deploy EFP or RPF at the interface, at the customer interface of an AS. Every AS in the corresponding customer core can be considered as the source AS, and the local AS with EFP or RPF deployed can be considered as a validation AS. That's a simple example. And next, we define SPA and SPD. SPA is source prefix advertisement. Source AS can use SPA messages to advertise the origin source prefixes of itself to the validation AS. And the source AS can also use SPD message to discover the active incoming directions of the source prefixes advertised in SPA. With the help of SPA and SPD messages, validation AS can generate sub-rules locally. So how to use SPA and SPD? Here I will introduce 3 use cases. This is the first one. In this case, we can combine EFP or RPF and SPA to help reduce improper block problems. In this slide, it shows a case of DSR scenario. I will not introduce the details of the scenario. You can refer to the problem statement draft for more details. In this scenario, there may be improper block problems if we enable EFP or RPF at customer interfaces of the validation AS. In the figure, AS4 is the validation AS, AS1 is the source AS. AS4 doesn't learn the anycast prefix P3 from AS1 in BGP updates. So the packets with source prefix P3 coming from AS1 will be blocked at the customer interfaces of AS4. The solution to this problem is that AS1 can use SPA messages to tell AS4 that P3 is also one of my source prefixes. So the P3 will be included in the block list of the customer interfaces of AS4, and then improper block problem is eliminated. We have some convergency considerations. When the source AS withdraws prefixes, there may be improper permit problems. This is because AS may spoof the source prefixes and the spoofed packets will be permitted as the AS4 because the prefixes have not been withdrawn by the source AS during the convergence stage. And when source AS update prefixes, there may be improper block problems, which may slow down the new service provisioning with the new prefixes. but the existing services will not be impacted, and only the services using the new anycast prefixes may be impacted during the convergence stage. For the security, as the source AS may hijack other AS's source prefixes in the SPA message. So we can conduct ROV on the SPA message at the validation AS. If the source prefixes in SPA messages are covered by ROA, the hijack in SPA messages can be prevented. But when the source prefixes in SPA message are not covered by ROA, the hijack in SPA may result in improper permit, but no improper block. This is because the Ietf or RPF uses the source prefix permission list. So this solution should have the same security level as the Ietf or RPF. This is the second use case. We can combine Ietf or RPF and SPD to help reduce improper block problems. In this case, let's consider the no export scenario. There may be improper block problems at the validation AS, that is AS4, because AS4 doesn't learn the existence of AS1 from the customer interfaces through BGP updates. So the packets coming from AS1 with P1 and P6 may be blocked at the customer interfaces of S4. So the solution is that S1 can advertise the active forwarding passes reaching S4 so that S4 can learn the existence of S1 and include the source prefixes of S1 into the permission list at the customer interfaces. We have similar convergence considerations as the first case. About the security, let's consider two kinds of attacks. First is off-path attack. It means that the attacker is not on the path, is not on the propagation path of the SPD message. So in this case, there may be improper permit problems. And for the on-path attack, it means the attacker is on the propagation path of SPD. So there may be improper permit problems, but for the two kinds of attacks, there can be no improper block problems because in the no export scenarios, there should be multiple propagation passes of SPD. And as well as at least one legitimate SPD messages is advertised to the validation AS. The existence of AS1 will be discovered by AS4 validation AS. This third use case, we can combine loose URPF and SPA and SPD to help reduce improper permit problems. In this case, we can loose URPF is deployed at the provider interfaces. The solution, there may be improper permit problems when S3 spoofs P1 that is should belong to S1. In this case, we can solve the problem by using SPA and SPD. Source AS can specify the active forwarding passes to the source prefixes in SPA and SPD. And in this example, AS1 can specify that there are two passes reaching S4. It means that P1 will not arrive from the provider interfaces of S4. then S4 will block the spoofed source addresses of P1 at the customer interfaces. Then improper permit problems can be eliminated. And in this case, this solution is suitable to the scenarios where the source AS requires its packets to the validation AS must be forwarded over the specified passes, no matter there are redirection, hijack, or traffic engineering. It will not influence the forwarding should not influence the forwarding passes from source AS to the validation AS. We have some security considerations. There exist security risks that may result in improper block. So we just suggest that source AS advertise SPD messages from itself to the validation AS directly through eBGP. That means that the SPD messages should not traverse other ASs in this case, in the third case. We also define some working modes. We define SPA complete mode, SPA selective mode, SPD complete mode, and SPD selective mode. This will be introduced in detail in our upcoming draft. And we also give some suggestions on which mode should be used in the three cases. Next, we will finish the draft with the collaborators, and comments are welcome. Thanks.
Sriram?
So Nan, my question, Sriram from NIST. So my question is, the SPD message, they should be only coming from the customers in the ASS customer cone. They should not be spoofed from outside of the from an AS outside of the customer cone. How does the AS that is doing the SAV know whether the SPD message is coming from an AS within the customer cone or not?
Okay, thank you. Actually, we do not limit that SPD must be advertised from the customer cone. It can also be advertised from a provider direction.
No, but it could be another AS in a neighboring customer cone, and that is spoofing a message to the AS doing SAV. So there has to be some way for the AS to know whether the AS is doing the SAV on the customer interface side. So the SPD messages must correspond to customer ASs, and it should not be coming from an AS in a neighboring customer cone. So that's my concern.
Okay. Yeah, it depends on the use cases. In different cases, we have different usage of SPD messages. We can discuss it offline. Thank you.
Yeah, there's a security problem there. Yeah, we can discuss it on the list.
Yes,
sure.
yes. Thanks for your input. Thanks.
Yeah, okay. You can make it
okay.
again. Okay.
Yes, thank you. Hello, everyone. I'm Jing Zhao from China Unicom. Today, I'm excited to share with the advertisement of meta-sourced SAV rules using BGP link state. This topic is crucial for SAV rules management in our network. SAV rules can be generated in multiple ways, like static configurations or management tools. Different routing protocols also play a part. In real-world scenarios, routers often use multiple methods to get SAV rules, leading to multi-source rules. This makes management complex, especially as these rules can conflict and be dynamic. Let's look at some use cases. First, there can be a conflict between IBGP and the management tool. For an ASBR, IBGP might block P1 at Internet interfaces, while the management tool permits it as P1 is an any-cost IP. Second, IGP and BGP can conflict. IGP may block P1 from AS2, AS3, and AS4, but BGP allows it from AS2. Third, cell rules are dynamic, changing due to factors like prefix, reallocation, or link breakdowns. To manage these rules better, we can advertise them to a controller. This helps with monitoring and management. A centralized server can then collect these melt source rules from routers. The rule advertising protocol should be simple. With unified API for rule advertisement, it must be extensible to support new rule generation method as our network grows. Efficiency is also key, as it needs to handle dynamic rules well. Here, BGP-LS comes in. As a BGP extension, it clocks network topology state for controller, making topology collection similar and more efficient. Now that we have covered the importance of rule advertisement and rule of BGP-LS, let's take a look at the cell rules information that need to be carried. The first is source of cell rules, which protocol generates the carried cell rules. The second is node, which node mentions the carried cell rules. The third is that we also need to note the interfaces where cell is enabled. The fourth is the source prefixes that in the prefix list of the specified interfaces are important to include. The fifth is the validation mode. Whether it's block list mode or allow list mode is a key part of the information. Together, interfaces, source prefixes, and the validation mode make up the carried cell rules. To enable the advertisement of cell rules within BGP-LS advertisement, we have proposed two new NLI called server rule NLI, one for IPv4 and one for IPv6 respectively. We would like to get your opinions about this draft. If you have any ideas, suggestions, or concerns, please feel free to share them. Thank you for your attention.
Yeah, Peter.
Peter Pshenak, Cisco. Didn't Joel say that we should not do any protocol extensions in this group? And second, I don't believe BGP-LS is the right thing to distribute this type of information. It has been invented, to distribute the topology-related things. This doesn't seem like the topology-related stuff to me.
Thank you for your comment. We support this draft in IDR working group. And about your comment about the BGP-LS, we will take it into consideration and incorporate in the future improvement of the plan. Thank you.
Yeah, Jim, I want to ask one question. You know, normally we will run the BGP-LS protocol within one router within the S, but the service rule will distribute across the every router. So how can you? I think you have not considered how can you distribute the service rule within the IGP domain.
Yes, in the version of the draft, we design a server rule described clearly in the section 2, and we will consider the other way that distribute the server rules within the IDP domain in the future. Thank you.
Hi, this is Jeff Haas. The comment I would give you about BGPLS is that the state that I think you're trying to advertise is not appropriate to flood through the entirety of the BGPLS domain. It's a good state, a way to represent the state for an individual router, but the state should probably be sent only to the SAV controller. And that would change the procedures on how BGPLS would be operated. That's something to consider for your next version.
Yes, thank you for your comment.
Yeah, okay. Thank you. Only 4 minutes.
I'm last one. Okay, let's begin. Hello, everyone. I'm Hai Yang Zhang from New IG3C. Today, I represent the authors to share this presentation about the young module of Savnet. Okay. This young module provides a base framework to configure and manager and subsystem, including subtable and some rules. And it also specifies the module for the status sub-rules application. And this state module is designed by referring to the Savnet functions defined in the related drafts, such as two architecture drafts and the subtable draft. Okay, this page shows the operation of Savnet feature. Through the Savnet Young, the management plan or the network management system can send the Savnet configuration and the Savnet entry to the routers, and also can obtain the Savnet configuration and Savnet rules and the Savnet events from the router. Okay, this is the component of Savnet Young. The Savnet Young include 3 aspects, such as self-configuration, self-state, and self-event. Self-configuration include self-global configuration and interface configuration, and also include static self-rules configurations. Self-state has subtable and subnet interface information. Sub-events is a sub-notification, such as sub-warning information. Okay, recently, this document have updates twins, such as you see version 4 and version 6. Version 4 is add blocklist mode for the static subrules, and is also add the notification of 10 spoofing or subrules. And it is supposed for showing flow information blocked by the subnet in state and the configuration sections. And it also adds alarm threshold number of subnet rules capacity in configuration on the event sections. Lastly, it also add the statistics of subnet total packets in the state sections. The version 6 updates 2 aspects. One is up some description in the draft. 2 is up to the reference to the last version. Okay, next I will show the detail updates. I will quickly show this. This page shows the updates in the global configuration. Look at the number 1 and number 2 and number 3. This page shows the 2 updates in interface configuration. You can see the number 1 and 2. This page shows 2 updates in static sub-rows configurations. Okay, this page shows also 2 updates in subtable state. Also, this page shows 1 update in subtable states. Look at this picture. Okay, this last one is in the subnet events. Okay, next, this draft requires more review and comments, and we'll add the example of JSON format and the choice of the action mode for subnet execution. Lastly, we'll support sub-rows from more type of control plane protocol. Okay, that's all. Thank you.
Yeah, thank you. I think your model is very detailed, so we can discuss it in the main list. So thank you.
Yeah.
Oh, okay. Let's. Hello, Joe. Do you have anything to say?
Just thanks to all the presenters and to all the people who came to the mic to comment, because engaging in the discussion is what it's really here for. Thank you.
Okay, thank you. See you next meeting. Okay.
Okay.